All right, we are back into. I don't know if to call this a podcast because there's actually no podcast. These just go on my YouTube channel. But I've been talking to a lot of people in the SQLite world, and now we get to talk to the CEO of Turso.
Here I
So
am.
Glauber Costa is here with me today, and we're going to ask a lot of questions about SQLite and libSQL. But Glauber, do you want to introduce yourself first?
Aaron, thank you so much for having me. What a pleasure to be here. Happy to introduce myself. I'm Glauber, and I've been in the software space one way or another, more or less until since the year 2000. That was when I started getting interested in computers, software, things like that. In fact, the first code that I wrote that was not a Pascal code to calculate the date of Easter, because that's the kind of stuff we were learning at university, was PHP in 2002. Something like that. So I've done like way back then. Everybody keeps telling me that PHP is nothing like what it used to, and I'm just getting started understanding a little bit better of the modern PHP. But be it as it may, like the thing that really ticked my and that I really liked was low-level systems programming. And I also took a very early liking to the then crazy idea of just write software and release it for free in open source licenses. Today, this is how everybody does it. Back then, it was this completely cuckoo idea. So in the intersection of those things, there is Linux. So when I was learning some C, so I started looking into the Linux kernel and trying to understand a little bit more how the operating systems work. So I started contributing to the Linux kernel as a volunteer. And when I say contributing to the Linux kernel, don't think too much of me back then. It was really some like tiny couple of things here and there. Around 2004, and then in 2005, I just got hired by Red Hat. So I had a career doing this. I worked in a lot of things in the Linux kernel, storage systems, file systems, virtualization. Virtualization was the largest part of my tenure. And joined a startup in 2013 that initially was doing something related to operating systems, but then pivoted to a database company. And that is Scylla today in the NoSQL petabyte scale space. That is how I learned about databases. I didn't really have any exposure to databases before, neither not as a user, by the way. So because I never really built applications, except in the very early beginning, I was just like working in the kernel. I was actually not a user of databases. I just did not know how to. I still don't know SQL that well, although ChatGPT knows it extremely well. So I rely on ChatGPT to help me whenever I do need. But for around 8 years, so from 2013 to essentially 2021, I was at Scylla. And here now, I had a 1-year stint at Datadog, but clearly realized that Datadog was, by the way, a fantastic company. I appreciate them a lot. But I really like to be in small teams and building things and getting things done from the ground up. So founded a startup, and here we are.
That is quite the journey. I'm glad to hear you're one of us. You're a PHP enthusiast.
Yes.
Forget you haven't touched it in 20 years,
Yeah.
but you're a PHP enthusiast. We'll
It's
claim
always a part
you
of you.
nonetheless.
Yeah.
Yes, exactly. And then that's quite a journey from not being a database user to basically writing a database and now being a CEO of a database company. So
you know Dax from Twitter?
yeah, of course, everybody knows Dax from Twitter.
Everybody knows Dax. So some people like him. I love him. Some people don't. But like, I was talking to him the other day, and then he was telling me that his career path was unorthodox because he learned NoSQL before he learned SQL. And I said, dude, I wrote a NoSQL database before I learned any of them.
Yeah, those are both pretty unorthodox. I thought my path from being an accountant to a programmer was unorthodox, but I think writing a NoSQL database before learning, that's more unorthodox. So
the lesson here, Aaron, is that there is no orthodoxy, right? We're all carving our own paths.
Yes, that is the lesson here, and something I like about our industry, by the way. So you caught us up to you left Datadog after a year, wanting to like be on a smaller team, and that was, I think you said 2021 or something. So now we're in 2024. You're CEO of a company called Turso. You have you're the steward of a SQLite fork called libSQL. So catch us up between 2021 when you're like, I kind of want to go be part of a smaller team, and how we got to forking SQLite.
So I always liked being in small teams. So that's something that was always something that I appreciated. And Red Hat became a massive company. But when I joined Red Hat, it wasn't really. So when I joined Red Hat, I think it was around 500 people, which again, it is plenty big. But if you would compare to the options, like I did an internship, so I did have like a small internship at IBM. Like there's no comparison, although now they're one and the same to some extent. Like especially back then, like IBM had hundreds of thousands of people, and then you look at Google, Facebook, like those companies, they're hyperscalers. You have your head count in hundreds of thousands. And I never liked this very much because you at this point, unless you're one of the top executives, which you don't start your career as, you are a cog in the machine. And I always wanted to be a creative. I always wanted to be a person pushing things forward. So this thing about like just go do open source and do whatever you want was very attractive to me. And Red Hat had a culture like that. When I left Red Hat was something like 4,000 people. And it felt too big for me, right? Yeah. So I always liked that. I just thought that I needed to just go at this point in my career to be in a large company like Datadog and see how it is. And there were a lot of things that I liked about it. I'm not going to lie. But Pekka is my co-founder. And we always, even back then, like I know Pekka for 15 years, his career path is pretty much almost exactly the same as mine. We worked together in the Linux kernel, and then we worked together at Scylla. We always wanted to start a company together. And we knew that, like, what do we want to do? I don't know, but let's do it together. That was our mindset. I think pretty much awesome. like you and Steve. I mean, something that I appreciate a lot, seeing the dynamic that you have between you and Steve. Except that Steve sounds like a decent person. Pekka is a freaking asshole. I don't like Pekka very much. But the thing is, like,
I'm gonna have to get Pekka on next so he can defend himself.
No. But like we have this love-hate relationship that we're always like that, and always like for some reason we're always throwing punches at each other. But secretly he likes me. I mean, it's not mutual, but I think he likes me. But
no wonder you vibe with Dax from Twitter. Y'all have the same funny sense of humor.
Hairstyle. It comes from the hairstyle. Yeah. But be it as it may, I think that by the end of 2021, we were both ready to embark on that journey. When I left Scylla, which was beginning of 2020, late 2020, I wasn't really, and partially because you all remember what happened in 2020. I thought it was just a lot of risk to just go do a startup. I just had a kid recently. At the time, I have 3 now. And the world was completely bananas. Nobody knew what was going to happen. So I just felt like at that time, starting a company was not the best career path for me. Maybe it would have been. I just couldn't take the risk. But late 2021, I think Pekka and I were both ready to do it. And initially, Pekka was also not on board, but he came to a point that he was. And then in September 2021, we started this company, and the company was called ChiselStrike, and was a project that was in the data space, but it was not a database. One of the things that Pekka and I were always talking to each other is like, hey, we don't know. We just know that we're going to start together. We don't know what we're going to do, but please let's not do another database company because that sounds insane, especially after 8 years of Scylla. Let me tell you, if you're listening to this and if you plan to start a database company, maybe don't, because it is really hard. It is really hard. And the reason it's really hard is just there are so many. Like, look, if I may, I thought that there were too many database companies. And because of that, I did not want to start a database company. But then we got acquainted with the JavaScript ecosystem and the JavaScript framework. So, maybe starting a database is not that bad of an idea because there are way more JavaScript frameworks than database companies.
It's true.
But we were using SQLite. We were using SQLite very, very heavily in our project. So the project was essentially, I think it was not our idea either, but it was fair, looking back, to frame it as a JavaScript framework to write data applications. So that was the idea. And our idea was, look, embed SQLite to a runtime. So you would have something like Dino running with SQLite right there, and you go deeply in those technologies, change them if you need, so that they essentially become one and the same. And then you can you can just write TypeScript that is like persistent TypeScript. That was the idea. So you write an array, and that array is persistent. You don't mess with databases. You don't do anything like that. So that was essentially the idea of the ChiselStrike project. So we started doing this. I mean, SQLite was the obvious choice for us because it's pretty much the only database that you can hit this level of integration with anything, really. We did this for around a year. And in October, around September, so exactly 1 year, around September in 2022, we were growing frustrated because we saw a pile of bodies of people who tried to contribute code to SQLite. One of them, and I don't know if you managed to hit the author of that, it will be a great guest for your podcast. I don't know them, but we read extensively on the internet about it. There was a project called SQLite that were doing things very similar to what we want to do. Because think about it, it was like a JavaScript system to write persistent applications. Then you need to deploy this thing in somewhere, and you need to distribute data. So one of the problems that we wanted to solve was how to distribute data with SQLite. At least something that scales horizontally. And the architecture that we had in mind was very much like what SQLite had. And then we saw that they actually tried to contribute all of that code to SQLite, and the answer was just no, not going to happen, because this project is not open contribution. Which, by the way, I want to make it clear, I fully respect. I don't think they're doing anything wrong about that, which is I want to clarify this point because this is something that I understand that some people has as a misconception, that I don't like this. Now, this is not the way I would handle a project. I come from a different culture. I come from this background on the Linux kernel, where the Linux kernel was essentially this one big party in which Linus Torvalds essentially said, this is never going to run on anything but my PC. And then 30 years later, it powers everything because people came with those requirements and said, let's stretch it in this direction and in that direction and in that direction. So this is how I would run a project. But I don't think there's necessarily, and there is in fact some merit to what SQLite does. And there are almost everything in life, there are advantages and there are disadvantages. So you can't be too strict and say this is the way, this is not the way. But for us, we were really just like, look, the changes that we want to make to SQLite are they can get quite intrusive, especially like if we go down this path, it can get quite intrusive down the line. I don't think we want to be maintaining like just this private fork, because there is a lot of problems with that as well. Like there are trust issues, because then you're not running real SQLite, and people want to understand, like, so do I trust this thing? Do I don't trust this thing? We also saw a lot of people who have done forks of SQLite before, which, by the way, is my understanding that the author of SQLite, at least externally, encourages, in the sense that you don't like it, just fork it, which is the open source way. I'm not saying that he's happy or unhappy about that, but that seems to be the at least his stance for what I've seen. We saw a lot of forks of SQLite that were just SQLite plus this one feature. So SQLite plus encryption, SQLite plus this, SQLite plus that. And this also didn't resonate well with us, because that's not how Pekka and I built communities in the past. And the number of people that you can find that are like SQLite, that interested in this niche thing that you're doing, is usually pretty small. So we had this idea, like, what if we just fork SQLite as a whole and create the open contribution version of SQLite? And we did it. And the funny thing is that we had Pekka and I met. This wasn't our first idea. Our first idea was, let's rewrite this in Zig.
Of course. And of course.
Look, 10 years ago, I think that is probably what we would have done. But we're getting too old for this. It was like Scylla. That's exactly how Scylla was born, by the way. Just rewrite an existing database in C++.
No way.
Yes, Scylla was a rewrite of Apache Cassandra in C++. That's how it
I didn't know
started.
that.
Yeah. With a different architecture and etc. And it's not that it doesn't work. I mean, it can work, but I think we had PTSD through the experience.
Yeah.
There are a lot of problems. Like Scylla, it's been more than 10 years, almost 10 years now. And there are still some small compatibility issues, some things that work on Cassandra that don't work at Scylla, because you're going to be chasing them forever. So we thought that, hey, look, I mean, we are in a point of life that we just want to ship stuff. We don't want to spend like 2 years just writing something from the ground up. We've done it, and then we don't want to be chasing compatibility issues forever. So let's just fork it. And then we add the stuff and then the second thing, it was like, okay, so what is the minimum amount of code that we need to write to show that, hey, this is a fork of SQLite and that's what this, so what are the things that we need to do to get people interested? Because we really wanted to create a community of people that would come and build with us. That was our main goal. I said, if everything fails, but we build a community here of developers that are building this thing together, we succeeded, right? Now, my kids are not going to like that I succeed like that because I'm going to be poor, but at least, internally, I'll be happy. Or at least I can claim that I'll be happy. I don't know. And the answer to that question, what is the minimum amount of code that we needed to write to prove that, and to show the direction that we wanted to take after maybe 2 or 3 days of deliberation, we got our answer. The minimum amount of code was 0. We just did not write any code. We wrote a letter essentially saying this is what we intend to do.
A manifesto.
Pretty much a manifesto. And we did it on purpose because we thought that, hey, it doesn't matter what we claim. If we write replication code, which we later did, we're going to be known as the SQLite plus replication.
Right.
If we write whatever encryption code, is yet another SQLite plus encryption. If you write this code, we're going to be associated with whatever the first thing it is that we put it out there. And look, the reason we're doing this really is that we want to extend this thing in all possible directions, and we want to hear from the community, and we want to give the community an opportunity to extend the way they like. So let's not write any code. Let's just write a manifesto and see what happens. If people hate it, they hate it. If people like it, they like it. And then we'll see what happens. And then a lot of people on Hacker News actually accused us of being all talk and because we didn't write any code and etc. But by and large, we had a positive reaction. And we got 1,500 GitHub stars in 2 weeks.
Wow.
And, we decided eventually that, hey, look, I mean, we don't really want to run a database company because that sounds crazy. But it seems like there is a lot more here. And for comparison, ChiselStrike at the time had 1,000 GitHub stars after 1 year of work. And it's not that GitHub stars are the most important thing in the world, but they are a proxy for like the amount of interest that this thing generates. In 1,000 GitHub stars, I mean, a lot of projects will never hit it. So it's not even like a small number. It's a decent number for a company that has been doing this for a year. It's plenty good. But we had in our hands like this project here. And then this other thing that we just released, and in 2 weeks got 1,500 GitHub stars, like which is 50% more. So it's pure interest with no code changes. So the last part of the puzzle was, and by now there was already November. The last part of the puzzle was just Pekka and I say, okay, so what is the business here? Because we are, after all, a company. A fork of SQLite is not a business, so we need to figure out something that is a business. And then we came up with the idea of Turso. We coded private beta of what Turso is today, essentially between November and February, like December to February. Put it out there, and the rest is history. It was a huge success.
So at that point, you guys, was it just you and Pekka at that time doing ChiselStrike?
No, we had raised a fair amount of money, and we hired a bunch of people. So there were a lot of, and there was a very uncomfortable time at the company because nobody truly knew. And we were very upfront when we saw the results of that. I said, hey guys, look, I mean, just it feels to us like this is a better direction, but I don't think we're ready to pull the trigger until we see a couple more data points. So a couple of engineers kept working on ChiselStrike tasks that they had. I said, I don't think we're ready. It's also, we discussed, I mean, let's just get the whole company to come and do this new thing for 3 months just to, but it can also be counterproductive because none of us truly knew exactly what we wanted. So Pekka and I really just had to sit down and say, okay, this is the direction that we figure out we want to try to go. So it was not going to be very productive to just bring the whole crew anyhow. But it was an interesting transition period at the company because people didn't really quite know what was going on. But by February, I think it was obvious. It was fairly obvious because once more, in February, we put this landing page out that just said SQLite at the edge, sign up here, and we got 500 emails, right? Just on a landing page like that, plus the GitHub stars and people started coming to the Discord community. So what more validation do we need? Right? Let's just pivot the whole company. So around that time, we just completely abandoned ChiselStrike and went all in on Turso.
Hey, I hope you're enjoying this. Just as a reminder, you can learn more about SQLite at highperformancesqlite.com. I'll get out of your way. Back to the interview. Okay, so you and Pekka and the company are working on ChiselStrike, which has some sort of dependency on SQLite. And you're starting to look at SQLite and you're like, man, this is kind of frustrating. We can't land any of these changes that would make ChiselStrike faster, easier, better, possible, any of the above. And so you're looking at SQLite and you're like, this is kind of frustrating that they're open or they're source available and not really open source. And like you said, that's neither here nor there, neither good nor bad. It is reality though. Like if you're trying to land changes and you can't, well, then you're kind of hosed. And so you and Pekka are looking at it and you're thinking there might be an opportunity to do this thing that we've never wanted to do, which is do a database. And so you fork the database, you fork SQLite, and you write a manifesto. And the manifesto just sets out your vision because if you can't sell the people on your vision, then there's no sense in spending all this time writing code that people won't buy.
Still, the intention was not to pivot the company towards it because the thought was, obviously, we want to create a successful community because everything you try to do, you should try to be successful at what you're doing.
Yes.
But our thinking was, I don't think there is long term we'll be healthy at ChiselStrike. So that was still the main goal. We're not going to have a healthy outcome running a specialized fork of SQLite. So we either abandoned SQLite, which we didn't want to do because we really loved it, or we try to create a community around this thing that will have all of those changes because then the credence comes from that community. So say, hey, I mean, so if we succeed to create a community here, then ChiselStrike, the project, will benefit. So that was the goal. But in my mind, creating a community on this would take 6 months to a year, and it will be a very slow process, and etc. And it wasn't what happened. So the huge success of the libSQL fork was what led us to think, okay, so this thing is in fact so successful that maybe we should just do only that, and the rest of the thing that we're doing is not that important, right? This seems to be resonating a lot more. But it was not our original intention.
Yeah. So you had forked it to serve the needs of ChiselStrike, and then were surprised by the reception and thought, hang on, this is getting more interest than our current product, so we should at least consider exploring what this looks like. And this is interesting, I think, just as kind of like a side principle for people listening, that like once you're in motion, things just happen and ideas just present themselves. And I feel like this is the same story as Tailwind. I mean, Adam Wathan was live streaming himself building out a SaaS product that he was working on that he was going to use to sell his info products. And while he was streaming, everybody was like, hey, what's that CSS library you're using? Hey, what's that CSS library? And he's like, it's not a library. It's just this file that I carry from project to project. And enough people asked that he finally just was like, great, I'll package it up, and it's Tailwind. And now, of course, we know Tailwind is an empire. And so I think it's just so, like, it's such a good life lesson that once you get in motion, that just begets more motion and more opportunities and more things that you can do. And I just love that is your story as well.
It is, and you have to be paying attention and open to that change, right? And it's also when you tell the story, of course, you're telling a sanitized version of the story. You don't put all the struggle that goes inside you. But if I may be open about that, I mean, you do have that struggle, because when you tell it sounds obvious. Oh, I had this sign and then that sign, but you also have doubts, right?
Yes.
It's something like, okay, so I've been building this thing for a year, and there is a community here which it dwarfs in comparison. I think ChiselStrike, the Discord channel at the time, had 400 people, and after a year of ChiselStrike, Turso today, our Discord channel has 4,000 individuals after the 1 year build. Now, after 1 year of building Turso, I can clearly look back and say, wow, that was definitely the right choice, but it didn't necessarily feel like it at the time. It was a very scary choice, right? It was okay, so maybe maybe we just got like a lot of people who are ready to press a button and say star, but does that mean that they're going to use this thing? And right, just
Right.
And at some point you have to take the plunge, but that's essentially what happened to us.
Okay, so you and Pekka and the crew, you fork SQLite into libSQL, you write a manifesto, you get a ton of interest, and then you decide to turn the ship. And so what is the first thing, what's the first thing you and the gang put into libSQL, and did that come directly from y'all to serve the needs of Turso, or did you start by incorporating a bunch of open PRs that were on SQLite that were never going to be addressed? Or what was the first move for libSQL after the manifesto hit and people are like, yeah, let's do it?
There were no needs of Turso at the time, so definitely not. But the first thing that we did was to just write, allow you to create user-defined functions in WebAssembly. So cool. SQLite allows you to create, and by the way, this is something that is just not, it ended up not being very interesting for us at Turso. It is not something that we allow people to do in the Turso platform for a variety of reasons, but it is the first thing that we added to libSQL. SQLite allows you, as you know, to define functions. Those functions are usually something that you write in C and just put there, and then you register the function. Now, we wanted something with a create function syntax in the language. That SQLite, you just called a symbol, a C symbol, and register the function. So we wanted a more flexible way to do this. This is something that we also happen to have at the time somebody in the team that is incredibly highly skilled with WebAssembly. He had done a similar thing for Scylla to allow you to write WebAssembly functions. So it kind of just felt like, let's see, let's try and let's see if there is any interest here. But at the time, it was still very experimental. And then the second thing that we added was essentially the ability to do native replication. And this is still one of the core parts of what Turso is. Right?
And so this native replication, at what point was this for ChiselStrike, or at this point are y'all starting to bat around Turso and this native replication enables Turso to exist?
More the latter, because by now this was already again November, December. So Turso did not exist yet as a concept, but Pekka and I knew a couple of things. So we knew that we wanted to try to put something out there to see if we could build a company just around the fork and not around the other bits. So that was number one. And we also, we knew we would involve replication in some way. The code that we had for ChiselStrike was way different. Like the internal code that we had for ChiselStrike was using Raft for consensus, and it was much more complex. And so we had this idea on our mind of what Turso could become, and then we wrote the replication code to serve that. Right?
Gotcha. So let's get a little bit technical. So there are some ways from the outside in to do some replication, and people treat SQLite as a black box and kind of do their stuff around it. How does native replication work in libSQL?
So SQLite has, and the other day I got into a Twitter fight with someone about that. But part of that is that people sometimes don't know that SQLite has two modes of operation. And the fight was around whether or not SQLite allow reads when it's writing to the database. And the answer is obviously it does. But the reason the fight exists in the first place is that it didn't at some point. So SQLite has two modes of operation. One of them is called the journal mode. And I think most people don't even use this anymore. Modern SQLite has something called the wall mode. So wall is called write-ahead log. So in wall mode, you still cannot have multiple writers, but you can have readers concurrent to writers. And even the concurrent writer thing, I keep thinking this is so unimportant. Like people have this idea that, I can if I write something, the other writer is going to fail, so I can't really do concurrence in SQLite, which in wall mode is completely untrue. At the database level, at the lower levels of the database, yes, those writes will be serialized, and you're not going to have two at the same time. So adding cores and adding threads will not help you. But what that means is that the second write will wait for the first. So it's not, from the point of view of the user, you just do a bunch of concurrent writes. It just works, right? You're limited in throughput, though, because you cannot do this from multiple cores. So that's essentially what it means. So there is this data structure in SQLite called the wall that allow those things to happen, that is already there. So the code that we wrote replaces the SQLite wall. So it does two things. First of all, it adds hooks in the SQLite core library so that you can have an external implementation of the wall. And then it provides this external implementation of the wall. So every change that libSQL does not work in journal mode, by the way, because of this, because the core of what we're doing relies on the wall. The wall, as the name implies, is the write-ahead log. So the write-ahead log contains the newer changes. The way it happens is that you make changes, so you don't make changes to the database file. You make changes to the write-ahead log, and you keep writing different segments of this write-ahead log. And then every now and then, you come and compact the database file together with the new segments of the wall. Otherwise, you would end up with an infinite amount of space. So every now and then, you have to compact that back into the database file. So we have, first of all, the hooks to allow anybody to come up and provide their own virtual implementation of the write-ahead log. And then we have one particular implementation of the write-ahead log that is the implementation that allows replication to happen. So I can ship this write-ahead log to a different instance, and that instance can receive this new write-ahead log, and then write that in the SQLite disk format. So when in memory, those things are not like SQLite to allow replication to happen. But on disk, when it's materialized, it is always in the SQLite format. Because then what happens is that if you open that file with SQLite, you would still be able to read it just fine.
Interesting. Okay, so y'all have taken the write-ahead log idea and made it abstract, and presumably the SQLite implementation is the first concrete version of that.
Yes.
And then you wrote a second concrete version. So this is already feeling similar to SQLite's internal architecture for, say, the VFS stuff.
For example.
You have an abstract and a concrete. And so you've done the same thing, but for the wall mechanism. Left SQLite as one concrete implementation. Then you have this replication-friendly one as a second concrete implementation. And what you're saying is that as it is represented in memory, you're able to do something special where it sends it off to somebody who's listening, but once it writes it to disk, SQLite or libSQL will pick it up as if it's a regular wall file.
That's correct, yes.
Okay, so then the implementation that sends it off. So how do you set that up? How do you set up who is sending, who is receiving, where are conflicts happening, who's the source of truth? Talk to me a little bit about that story.
Let me take a step back, if I may. So one of the things, and then I'll converge those things. One of the things that a lot of people will also claim is that I love SQLite, but I am deploying my things on serverless. I am deploying it on Cloudflare Workers. I am deploying it on Vercel. I am deploying it on AWS Lambda. SQLite doesn't work well in those environments. So that was another thing that we wanted to make happen. So to make that happen, we also wrote something that initially we put in a separate repository, which in hindsight was a big mistake. And then we fixed this mistake. The good thing about life, Aaron, is that if you make a mistake, 9 times out of 10, you can fix it.
Most of the time, yep.
I'm not claiming here that all mistakes are fixable, but software does have a
software approaches 10 out of 10 fixable mistakes. Yeah,
no, 9.5 out of 10. Let's give some room for doubt. But so we wrote something called the libSQL server, which today is part of libSQL in the same repository, and it's all in the same. But at the time, we wanted to. The reason we wanted to do this is that we didn't want to muddy the waters between like what is the thing, because people see SQLite as this thing that is just a file. What is the thing that is the file? What is the thing that is the server? But I think our insistence on getting this into different repositories ended up muddying the waters even more. Because especially for Turso, we heard people saying, oh, those guys are sketchy because they're claiming that their things are open source. But you go look at the repository that they point to, and it's just a library, like all of the server functionality. And we say, no, but the server functionality is in this other repository. But by the time I have to explain this, right, I already created a bad impression. And so we merge, and also had a lot of practical build time complications as well of having to synchronize 2 repositories. So we merge them together. So there is something on libSQL called the libSQL server. And the libSQL server is essentially a protocol plus an implementation. So the protocol is also open and anybody can implement. It's a protocol plus a implementation of SQLite over HTTP. So it allows you to essentially do SQLite over HTTP, including transactions over fully stateless HTTP. So you can do interactive transactions, you can do whatever you want. And this allows you to use libSQL on Cloudflare workers, because what you do is that you put a server close by. Now, the binary is not going on Cloudflare workers, but that's fine. But now you're connecting to libSQL over HTTP. And when we released Turso, by the way, that was what Turso did. I have those replicas across the planet, and now you can connect to the closest one. And I auto-select what is the closest one for you. That was it, right? But this server is what handles replication. So the server is what you connect to. When Turso today and libSQL in particular have 2 modes of replication, which is server-to-server replication. In server-to-server replication is something like I have a primary, which is the source of truth, already answering some of your questions. The model is very simple. SQLite is very simple, and we want to keep everything that we do very simple. That is the goal of this project. So there is a primary server, let's say in Dallas, close to you.
That's a good choice.
And you can then create a replica in Toronto, close to me. Those are 2 servers. You connect it over HTTP, and Turso will, and this is a part of Turso, not libSQL, because this is mostly infrastructure setup. Turso will connect you to the closest replica. But if you're really talking about pure open source libSQL, again, it's very simple. You have a primary there, you have a replica somewhere else, or in this one server or in this other server, and then you just connect to one of them and get the data that you need. Simple and easy. There is another mode, and in this mode, again, the primary is the source of truth, and the replica polls the primary, say, hey, this is the last replication index that I received. Send me your stream since that point. And then I keep track of the replication index, and I'm always asking the primary, give me all of the data since this point in time. And then the primary is not sending things before the replicas ask for it. So it's a poll mode replication. And then the other thing that we added later, which is one of the things today that people absolutely love about Turso, is that if you think about it, this allows you to use SQLite in those environments that you couldn't before. So you can start your tutorial, you do your Laravel tutorial with pure SQLite, and then if you deploy this to a serverless environment, you can still use the same SQLite because now you're talking over HTTP.
Right.
But that's not really how SQLite works. I mean, a lot of the SQLite magic happens because of the file thing. And again, people already loved it that you could develop in a file and then just switch the URL and that goes over HTTP. That was already magical. But what we allow today to happen is something that we call embedded replicas. So embedded replicas is essentially a file. And the same way that a server replica can query the primary and every 200 milliseconds and say, give me the delta since that point in time, the library itself can do that for you. So you now have a application running SQLite as you would at any time, and all the writes are slower. In all fairness, at least for now, we plan to fix that in the future. But the writes are always going to this primary and getting back to you. But when you read from the file, and even if you have other writers, right? Even if you have other writers. If you don't have other writers, you can use this as a backup solution. It's not that interesting, but it does work. But the powerful scenario is in which you can have now many writers. So you can essentially scale out your application. Each one of them will have a local file. So you're always reading from the local file at 0 millisecond latency for networking. And every configurable by you, 500 milliseconds, 1 second, or whatever you want, you pull this primary, and then you just get the data back. And that data is materialized in the file, right?
This, I think, is the most interesting and powerful thing. I think this is my favorite. So to say it back to you, you have a primary somewhere. So you have the primary, let's say, in Dallas, and then on every server or edge node or wherever you're deploying your application, you can have these embedded replicas. And so anytime you have a write in your application would have to have read write set up already, which most frameworks have. So Laravel has the concept of a writing database and a reading database. I feel like that's pretty normal. So you send all of your writes to the primary, and then the libSQL that's sitting next to your deployed application is constantly polling that primary and pulling changes in. So when 80% of your traffic, 90% of your traffic is reads and not writes, which I think is about standard, 90% of that traffic is hitting the database that's literally sitting on the same disk right next to you, right next to your application. But you still get that benefit of SQLite being embedded, but you get the benefit of a more traditional or a different style of database where you can have a bunch of writers coming to one point and then replicating out.
Pretty much. As long as you have a file system, you can do this. And which one misconception that means that it doesn't work on AWS Lambda, it doesn't work on Vercel. That is half true, because it's usually not the recommended setup. But you do have a temporary file system in those environments, and this tends to be recycled. So for a small amount of data, for a lot of data, it doesn't work, because for a large amount of data, you have to be downloading the whole file all the time. But for a small amount of data, and we actually have a blog post explaining that, you can write the database to the temporary file system. And check the modification, because if you have to now contact the server to see if this is up to date, you already lost the benefits, right? Might as well do HTTP. So what we recommend is that you use the temporary file system, you check the latest date of modification, like the timestamp on the file. If it's less than, let's say, a second ago, it means that you just read from the file. If the modification timestamp is more than a second, or if there is no file, that means that you got a fresh container, or you got recycle, or last update was a period that you don't consider fresh anymore. Then you just sync first, and then you read. So you can do this for a small amount. The thing is that if you don't have a long-standing server, this is going to happen a lot more often. And it just is not worth it if you have like a gigabyte of data. It still works well if you have like maybe a couple megabytes of data. But if you're deploying something, let's say on Fly.io, on Render, on Koyab, on AWS CC2, anything where you have a server, you have a file system, you can even use like ephemeral volumes, because if your file system, if your container dies and you have to replace it, at that point, Turso will automatically you download the whole file again, because it's the first sync. It's just that you provide no index, you get the whole file. In a long-standing server, that doesn't happen very often, so it's still worth doing it. So you don't even need a persistent volume. You can use just a temporary file system, a ephemeral volume. You can use whatever you want.
That's interesting, and that makes a lot of sense. So is the blessed way to use Turso in a serverless environment most of the time, without those caveats, the HTTP method?
Yes. Yes.
Yeah. So it sounds like in certain cases it might be okay to pull it down and put it in the temp storage, but for the majority use case, you're going to use that HTTP mode of Turso, which, yeah, that makes a lot of sense. Do you see a lot of people, as far as like your customers, do you see a lot of people deploying in serverless environments, or do you see a lot of people putting it in something like Fly, where it's like quasi serverless, but there are still actual servers, long running servers?
Fly has nothing serverless about them. It's pure servers.
But it feels so serverless because you can still SSH in, so it's not serverless,
exactly,
but it feels so serverless.
Yeah. You have the granularity of a server, and you can have things like Fly does allow you to like have something that comes up, serves a request, and goes down.
Yeah.
But this is always backed by a server, right?
So where do you see a lot of people, like what's your split, if you had to guess, of where people are using Turso?
I think it will be close to 50-50. And it might be a little bit more like embedded replicas were transformative. I mean, when we released this, we just got a completely different class of people coming. Right? It was very. I think JavaScript is still our leading language, but when we released Turso, it was like by a large margin. Like 90% of the people were really coming from JavaScript. After embedded replicas, I think this became a lot more appealing to and this is, I think, just because most of the function as a server things run with JavaScript.
Yeah.
Now we have a lot of PHP developers coming. You know that because I told you we didn't have the bandwidth yet to do a official PHP driver, but we had 3 different community contributors contributing PHP drivers for usage with Turso. And then we decided to sponsor one of them that seemed ahead of the pack. But again, look at that. I mean, before you can even have a driver, people are already like hooking something up to the best of their abilities because they really want to use this. So this idea of embedded replicas is just really, really powerful. And it's something that marries the benefits of SQLite that people have been knowing and loving for 2 decades with how you run a production Postgres like MySQLite database. Right?
Yeah, the reason I like this embedded replica system is because the majority of traffic is going to be reading the database and not writing. And so you get the majority of the benefit by just treating SQLite as a nearby read, and then you can write, and those can incur a little bit of penalty because it's less frequent.
And I want to clarify that there is a performance penalty in writing, because now you writing not only like you're not going to be as fast writing remote and writing locally. That is obvious. And also the way we write, like it's a little bit more expensive than a normal Turso write as well, because now you have a full round trip to get things to come back. Because we do want to provide read your own writes consistency. If your replica writes something, you will read your own writes, which is much better than a fully distributed cache in which you never have those guarantees. But you don't have to set up anything for that to happen. So it's not that you have to be aware that all you have to do is to write. So the code doesn't change. The code still reads and writes. Reads and writes. There is no setup involved. It's just that it is faster or slower. That's it.
So from the perspective of the application, with embedded replicas, am I just writing and libSQL intercepts that and sends it off to the primary?
Yes.
That's the ticket. Yeah. That's the move.
So you don't have to have an external. Oh, now I'm going to do an external thing. Which is my impression was that you were understanding that way. Like you just write specially. Right. You don't even have to do that. They're just slower because you're now being intercepted and writing to the primary. But from the perspective of the code, you just read and write. There's nothing there.
I like that. I like that you hide that. You hide that behind your implementation or your library, not mine.
And once more, this is only possible because we forked the whole thing. So we have all of those entry points where we can add the stuff that we needed, right?
Right. Okay. So the thing that I've seen recently that I think your very smart co-founder Pekka has been working on
we'll agree to disagree on that, but
I saw that y'all just released some sort of vector search embedding stuff for SQLite, which of course is like everybody is clamoring for vectors these days. So tell me what your very talented co-founder has been cooking up over there.
Yeah. So just to clarify that I am mostly joking. Pekka is actually sometimes quite smart, but here's the conclusion that we got. Like every database company today faces pressure to respond to the rise of AI.
Okay.
But what we never wanted to do was do it just for the sake of doing it. So it just doesn't match our style. That's not what we want to do, and that's not who we are as people. Like we want to make sure that whatever we're doing has a big benefit and the market will appreciate. Otherwise, we've got tons of other things to do. We went through a laundry list of ideas of like, do we have a natural advantage for SQLite for this thing in the AI market? We even said, can we run SQLite in the GPUs? And we found some academic papers of people who tried and got good results. And, we explored a bunch of those crazy directions. And eventually we understood that vector search is not that different than any other form of database operation. And the same things that people love about Turso, that people love about SQLite, and that people love about this idea of like, hey, run something locally, replicate, do embedded replication. And just one of the things that people appreciate about Turso so much, how cheaply we can make the service available with a very generous free tier. All of those things would be just as applicable to vector search. There is an extension, which I understand is getting deprecated today, called SQLite VSS, that some people in our community were using to do vector search with SQLite. So you can load this extension. This extension allows you to create a virtual table on SQLite, and on that virtual table, you can essentially do vector similarity search. We talked to a lot of those users, and then we understood that one of the things that they didn't like about it was that loading the extension was not great. Like just it's this thing. I mean, it's okay, but I have to do something about it. And then every time that I'm using it, I have to load the extension. The developer experience, a lot of people told us it's just not there because I have to create a virtual table, and then I have to then get this virtual table to work with the rest of my data, which is not in the virtual table. Imagine, for example, you have a table of users, and then you have to have some vector representing that user. How do I query those things together? None of those things were things that people in our community like very much. And now, as I said, we have a 4,000 strong community on Discord. So we have a lot of data to just go and chat with some of those folks. And then we said, look, the whole reason for the libSQL project is to be able to change SQLite. People don't like the fact that this is an extension. But people keep telling us that, look, other than that, this sounds incredible for vector search, because another thing that we didn't explore, creating a database on SQLite is just creating a file, right? So it takes 100 milliseconds, and you can create 100,000 of them if you want. And if you want to do a database per user, go do it. If you want to do a database per body part of the user, go do it. If you want to do a database per hair, hair strand, you may be able to do it. I can't. Like just do it, right?
Would it be a no op for you?
Exactly. Yeah. But I do have a lot of body hair though, so like if you're counting the whole thing, okay. I need a lot of databases.
Yeah, well, keep going. Move on.
but a lot of people seem to be interested in that. Look, if it wasn't for the fact that this extension is cumbersome and it had a lot of technical limitations, Turso will be a perfect database for running those AI applications, because I can run like per user context. I just put different users in different databases. I can put this on my mobile device. Embedded replicas, by the way, we are a little bit low. The drivers are not that great, but conceptually they can work on mobile devices. It's just that working with React Native and et cetera, it's complicated. We're fighting that battle now. But conceptually, people say, "Oh, imagine that I could keep those things completely separated, and I could push to the user mobile device." I could do all of that, but like loading the extension, it's hard, and like the extension itself has a lot of problems. So Pekka, essentially, out of his wisdom, understood that the whole reason for this project existence is so we can do whatever we want with SQLite. So let's just do whatever we want with SQLite, and let's change SQLite natively. So it now has a vector column. And this is what we ended up doing. So if you can create now you can create a text field, you can create an integer field, you can create a blob, you can create a null, or you can create a vector, right? And it just works like that. And this is something that the community so far has been appreciating very, very much. Everything you want to do, by the way, if you want to use this without Turso, just purely locally with libSQL, you can do this as well. Because we're talking about all of those things that you can do. That doesn't mean you have to do them all at once. So you can just put this on a mobile device, for example, and now you have native vector search. And we also implemented a indexing algorithm to index those vectors. And it just becomes a part of your SQLite table. You will write a query like a select star from movies where year is higher than 2020 and the vectors are similar to those other vectors. You just do that and limit tree and order by the author, right? You write a SQLite query that now has vectors on it.
That is super cool. How long did it take y'all to implement this? And what is like what's the overhead or the maintenance complexity? How easy was it to do?
So again, it does help that Pekka and I have a lot of experience with C and very low level stuff. I think the hardest part was really some aspects of the developer experience are not exactly, they didn't end it exactly being how we wanted because some parts of SQLite were very hard to change. But by and large is fantastic. It took us around 2 months, and by the way, it was exclusively Pekka working on it. We didn't have any other engineer.
Pretty good, yeah.
You haven't seen, Pekka is a monster. He's out of this world.
Apparently.
Yeah, and
I mean, so for context, parts of the SQLite code base are 2 decades old, and from what I understand, DRH writes his C in a very particular style that can be a little bit obtuse, and so to be able to do that in 2 months is pretty impressive.
I appreciate the way you phrase it, Aaron. I think you're just a much more polite person than I am. Or with a richer vocabulary. This again, I want to clarify that SQLite is just a fantastic piece of software. It's extremely reliable, but the coding style is hard to follow, and I think as a result of being maintained by a single person or close to a single person for 2 decades, and it is quite hard. But go look at all history that Pekka had in the Linux kernel. I was not a high-profile guy in Linux. I just created Zora, but Pekka was, and still is. I mean, Pekka is still one of the best engineers we have on the team. And as the CEO, I think that if I have to claim any credit on this, the credit was exactly for me to look around, and this is not to diminish the rest of the team, which are also fantastic engineers. We have people working from us, for example, the maintainer of the Tokyo library in Rust, and others that are extremely competent engineers, but they don't know C because they're all kids. And kids for me are anybody under 40. I think we can confidently call, like Kid. You, Aaron, you're a baby. Yep. You're a baby with your own babies, but you're still...
That's right, with many babies, but yeah,
exactly.
Still a kid.
But look, what I told the company is that I will moonlight as both CTO and CTO for the time being. Like I'm running the show now in both fronts, and you guys just leave Pekka alone. And now that it got to this point that it's in beta, but it's released, now we can start offloading parts of that, and we can just look at this as a normal project and go into stability cycle. But Pekka alone doing nothing else just did this in 2 months.
Man, he sounds like a pretty beastly engineer. That's very impressive. So what's next? Like in terms of, I guess, both libSQL and Turso, what's next? They could be the same or they could be different. What's on the horizon for each of those things?
it's still incredibly important for us to grow this community. So if you are a person that wants to be a part of that, this is why we started. We have a company around that now, and we moved the whole company towards this, but we never lost this dream of like making this a large community project, which we did, by the way. We have over 60 contributors to libSQL today.
Man, that's awesome.
So I would love to leave some of this future up to you, the listener, and show up. And we have contributors today doing things that we would not be otherwise doing it. And this is exactly what we want to see. That said, we do have a couple of things on the horizon for Turso. And obviously the things that we're going to be putting into the project are first and foremost for the benefit of the company. The things that we actively get involved with. First of all, we want to do more vectors. So we want to. There are a couple of things that Pekka are still working on and starting to hand out to other people. And not to get too technical, there will be like 1-bit quantization. If any of your audience heard of it, if not, follow me on Twitter, ask me the question. For embedded replicas, we also want to do offline writes. So again, today you still depend on the primary to be writing. So you always write to the primary. That is low because you're writing to the primary, and you can only write when online. We want to have a mode in which you essentially make your server the primary, and now Turso just becomes a distribution point. So we call this offline writes. That's one of the things that we want to do. This would move us even closer to the fantastic model of like doing SQLite things. And look, double down on a lot of things on the initiatives that we have.
I love it. Man, I love it. I'm so glad that you came on and explained all of this to me. I'm
Anytime.
Obviously very, very interested in the underlying technology, but also the business angle is super fun for me. So thank you for taking the time to do this. If people want to follow you on Twitter and argue with you about SQLite journal mode or wall mode, where can they find you?
They can find me on Twitter at GLCST, as in Glauber Costa. Please don't follow Pekka, because Pekka and I have this competition internally. He just wrote a book that is terrible about latency. I don't recommend anybody buy that book, because it's been every now and then he comes to me and say, hey, I sold that many copies of the book. And then he's trying to use this to essentially brag. And I just don't want to give him the fodder. So just please, if you're listening, just don't do it.
But I'll leave a link to the book in the show notes.
Aaron, did break my legs by doing this, man.
Okay, so follow Glauber, not Pekka, GLCST, which is a great handle. 5 characters. That's pretty good.
Pekka's is even better because his name is Pekka Enberg, and then his handle is P. Enberg, which I should not have said, but now that I did, just don't follow. You can visit his profile, just don't follow. There you go.
Go admire his profile, admire the book, but don't take any action. Okay. Well, thank you again for doing this, and y'all go follow. Y'all go follow Glauber and check out Turso. And until the next time, talk to you later.
Thank you so much, Aaron.